Welcome to this video and welcome to the first lesson of Unit 4, Probability. We're going to introduce basic theoretical probability. The collection of all possible outcomes for an event is called a sample space. Let's flip a nickel and a dime to observe the number of coins that land heads up. So N stands for nickel and D stands for dime. H stands for head and T stands for tail. The probability of the event E is denoted by P parentheses E, and it is the proportion of the time E will happen in the long run. And the probability of an event happen is always between 0 and 1 because probability cannot exceed 1 or below 0. And the formula that you're going to use is this E over S. And it's the number of sample points that meet the stated criteria divided by total number of equality, likely sample points. To put it into simple words, it will just be number of desired outcomes divided by number of possible outcomes. So the number that we want to happen over the possible outcomes that will happen. So let's take a look at an example. Flip a nickel and a dime. Let E equal to event of observing exactly one heads. Find PE. So PE is going to be, because we only want the probability of one head. So let's take a look at the probability right here. One head, there's 2. So total is 4. We use 2 over 4, we get 0.5. And the probability of getting no heads will be just 2 tails, so it will be only 1. So 1 over 4 will be 0.25. Another example, flip a nickel and a dime. What is the probability of getting at least one heads? At least one heads meaning we get 1 head or 2 head. So that's 3. So 3 over 4 is 0.75. Therefore, the probability of getting at least 1 head will be 0.75. What about probability of get at least there's another way to do it, which is using the probability of getting no heads, like that quantity, using 1 minus that quantity, you will get 1 minus 1 over 4. Same thing as 1 minus 0.25, you'll get 0.75. So there's 2 ways to approach this. So let's take a look at the multiplication rule. What if we were flipping 100 coins? Would we need to write out the sample space? Well, that would be very tedious. And think about that. This is only 100 times. What about asking you to find 1,000 times, 10,000 times, 1,000,000 times? And that will be impossible to write out everything. So therefore the math came to place. We turn instead to the multiplication rule. If one action has A possible outcomes and the second action has B possible outcomes, then the two actions together have A times B possible outcomes. So let's take a look at David's dinner sandwich possibilities. Those are the materials that I think of would contain in a sandwich, would include in a sandwich, like bread, meat, cheese, sauce, lettuce, veggies, blah blah blah. And we just did a fun experience in class. We asked how many people would want that kind of material in their sandwich, and we recorded the number. And then we times the probability of people would want each materials. And the quantity becomes this number, this huge number. So you can see this is the probability of getting different types of combinations of one sandwich. That would be a very huge value. And think about this. How many possible Colorado license plates are there if each plate is 3 letters of the alphabet followed by 3 digits? So we know that there's total 6 digits. And the first 3 digits are the 26 letters. Therefore, there are 26 possibilities to get one letter for the first 3 digits. So we put 26, 26, 26 3 times. And then from 0 to 9, there's 10 possibilities, sample space, for us to get a number. So therefore, we times 10 3 times, and we get this number. And what if I change the first letter of this license number to D or E? So it always starts with D or E. So therefore, we limited our possibility for the first digit to be only 2. And everything else stays the same. Therefore, we get a possibility of this. So you can see it shrinked a little, but not that significant because it depends on the sample space, right? Another example, what if a letter isn't allowed to be used twice on the same plate? So therefore, think about this. The first digit, we have 26 options. But the second digit, we already used 1 out of 26 letters. Therefore, we only left 25 sample space. And same thing as the third digit. Therefore, we use this number times the other 10 numbers, we get the number like this. The quantity is also very huge. And that's just another example we did on class. And let's think about this scenario. How many different ways problems require advanced applications of the multiplication rule. You need to know how to calculate permutations and combinations. So think about this question. You're then with 10 hungry CCHS students inside stops at the David's. So yeah, so basically the Gus is sitting right here, just out of frame, wearing a shirt that says, "I hate people," if you can read my little funny myth. So no one wants to sit with him, and he don't want to sit with anyone else. Therefore, the number of people is decreasing because no one wants to sit with him, so it decreases by 1 every time. And the permutation of 10... So what you can do is using this probability to get the number of probabilities that the numbers of people would like to sit next to him, and you get this number. And so what you can do is go into your calculator and just hit this number out, and you get this number. And what's important about permutations is about that the orders matters. It's different with combinations. Combinations, you don't care about orders, but permutations, order matters. Okay? So same thing. Now suppose instead that Gus isn't there, all four stools are equally desirable places to sit. So like Gus is not here anymore, therefore everyone can sit whatever they want. So order doesn't matter in this place. So we have 4 chairs, and out of the 10 people, 4 options to choose, we get a combination of 210. So compare these two numbers. You can see that permutations, you get a significantly larger number than combinations. And that's just a great way to look at the difference between these two. So let me re-explain this a little bit. I feel like I'm kind of a little blurry right here. So basically we have 4 chairs, first space right here available for 10 people to sit, but not like no one wants to sit next to Gus. The people who sit next to sit one of the chairs. Therefore, we left, like every time the Gus is moving his space, like he can sit here, but he can also sit here, here, and here. So no one wants to sit with him. So every time he changes his place, other people have to change their space too. So therefore we get this like quantity timing, like the formula right here. Because every time when he moves his spot, people would not want to sit with him, and only because he's taking 1 spot, we only left with 3 spots. The 3 spot. So the 3 spots has to be arranged. Therefore we get those numbers. Okay. And that's it for this video. And so in here it's just a little simply comparison with NPR is greater than NCR. But it's not the case every time, but most likely will be, at least in this scenario. So I hope this video just give you a general picture of how a probability work in real life and in mathematical ways. I hope you learned something from this video. Thank you so much.